Okay, so we're going to talk about variability. Um, Variability is how spread a data set is going to be. So just to give you points of reference, you may have a set with very, very low variability. So everything tends to be right around the center. You don't have, it's not very wide. You could also have a set with a lot of variability, so a really wide set. So that's the way that you can picture it. The data is very spread out versus, the data is very spread out if you have high variability, and data is very centrally located if you have low. Okay, so that's just keeping that keep that picture in mind. Now, if we want to actually figure out how do we use numbers to describe that, we need to look at some actual numbers. So we've got 8, 4, 7, and 9. So, again, normally you'll be dealing with a lot more numbers, but this will work for our purposes today. So the first thing that we want to do, if we're going to understand how spread data is, we need to first establish where is the center of our data. So we're going to want to do a mean here. Figure out what this is. So if we add all these up, we should get 28. Okay, so there are 4 numbers, so our mean is going to be 28 over 4, which equals 7, right? So 7 is the center of our data. So now we can actually go through and judge what the how varied this set actually is. So what we look at and where we start from this is deviations. Deviations are an important concept here. And what you do for a deviation is you take your observation, which this is like observation 1, 2, 3, 4, and so on. So whatever it is that you've found, and you're going to subtract away your mean. And that is what your deviation is going to be. So we're taking each of these numbers and subtracting away the mean. So let's compute this for each one here. So firstly, so we've got the first deviation that we have is going to be 8 minus 7, which equals 1. We have 4 minus 7, which equals negative 3. We've got 7 minus 7, which equals 0. And we've got 9 minus 7, which equals 2. Okay, so let's look at this information here. So we've got a 1, a negative 3, a 0, and a 2. Well, what we want to be able to combine all these things together because we're talking about a whole set. So normally we look to add. Well, something peculiar happens when we add this, and it does make sense why it happens. If we add 1 and negative 3 and 0 and 2, you're going to find that this answer is 0. And it's always going to be this case, unless, for instance, you had to round when you divided or something. You might end up with some sort of number, but theoretically, if you do things exactly right, you will always get 0. And this is not very useful to us whatsoever. So what we do is, in statistics, we take these numbers and we square them and then add them together. Okay, so we're going to square these numbers now. So, let me pick another color. So square them. So this gives me 1. This gives me 9. This gives me 0. This gives me 4. Okay, well, now I've squared those numbers. So they're all positive and they're good. So now I can actually go through and add all these up. So I get my 1, my 9, my 0, and my 4. And that gives me 14. Yay, 14. Okay, so am I good yet? Well, not quite, right? This number is just a raw number, right? It could reflect a data set of a ton of different points or just a few. In this case, we just have a few. We only have 4. If there were 100 different data points, that had these square deviations that summed up to be 14, that'd be a little different than just 4. So we have to take into account how big our set is. So what we do here is we take, and this is going to be for our sample variance. That is our sum of our squared deviations. So sum of squared deviations divided by the number of observations we have minus 1. So we come back, we look up here, we have, that is 4. So we would be dividing by 3 in this case. And the sum of our squared deviations is these guys right here. So that is to find our sample variance. So in this case, we would have, it would be the square root, 14 over 3, which would be, 4.67. Right, so that would be our sample variance. Now, a lot of times what we also do is we find what we call a standard deviation. And a standard deviation is simply the square root of our sample variance. Okay, so we just take our variance and we square it, or we take the square root of it and find our number. So in this case, it'll be a number slightly over 2, so it'd be the square root of 4.67. Now, it all starts with us looking back at our data, and when we go from our data, we look at these deviations and we find out, where they are in comparison with the mean. So, right, we got a number above the mean, below, right at the mean, above, and so that's helpful, but we need to work with that, and so what we do is we square it, and then we sum all of these numbers up, and that's where our sample variance comes from, is that divided by n minus 1, and then that's where our standard deviations come from, and so it's all just judging the data based off of the center of the data set. The next thing that we want to talk about is the interquartile range. So let's look at a generally normally spread distribution. You have in the middle, if it's symmetric, it'll be dead in the middle of this. You'll have your median, which is like the 50th percentile. Right, 50% lie below, and 50% lie above. Well, there are two other markers that we're going to have, and that's going to be what we call the first quartile and the third quartile. Now, the first quartile we will place and say we're about here. So this is first quartile. And what that is going to do is that is going to separate the bottom 25% from the second set of 25% of our data. Likewise, for the third quartile, it's going to separate the kind of the third set of 25% from the last. Now, this is just a way to split our data. Just to give you an example so it doesn't sound crazy. Let's say the median score on the ACT was a 21. That's about the median of what people scored. I'm just pulling these numbers out. It could be completely wrong. But let's say, that's the 50th percentile is at 21. So let's say we want to know what's the 25th percentile, which is down here. So again, this is 25th percent, and this would be the 75th percentile. Let's say that the 25th percentile is, let's say this is a 16, or let's call it 17. I don't know, 17, and we'll say that the third quartile, so the 75% is at 25. Okay, so these are, again, made up numbers. But that's what those represent. The first quartile is 25th percentile. The median, or the second quartile, is the same thing, is 50%. And then the third is at 75%. So this is important because there's going to be something that we call the interquartile range, which we look at how far apart the first and third are from each other. So if we look at how far these are from each other, which would be these right here, that's going to give us our interquartile range. So for this case, if we were talking about this made-up example that I made up, the interquartile range would equal 5. Or excuse me, 8. Losing my mind. The 8. Because the way that we figure that out is it's the third minus the first, and we get it at number 8. Now we'll use this information later on to help us kind of understand outliers, but right now we are okay with you just understanding what we mean when we talk about an interquartile range, and that's how far apart are the 25th percentile and the 75th percentile of our data.